So two things we are going to learn. One is elimination of left recursion. Okay, then left factoring. Okay, so these two are very important before you give a grammar to a top-down parser. You implement a grammar in a top-down parser for passing the given string. So what is left recursion? Is a grammar is left recursive if it has a non-terminal a, okay, such that there is a derivation, okay, such that there is a derivation of the form a derives a alpha, okay, in one or more steps for some string alpha. Agree? Okay. A grammar is left recursive because there is head of the production and the leftmost symbols are same. So a grammar is left recursive if it has non-terminal a such that there is a derivation of the form a derives a alpha in one or more steps for some string alpha. Okay, if at all, if you have a derivation in this manner, then it is a left recursive grammar. Okay, so top-down parsing methods cannot handle this left recursive grammars. So a transformation is needed to eliminate left recursion. So how do we do it? I will take an example and we will see how to do it. So if you can remember that we had this grammar, I asked you to remember this grammar, right? So for the arithmetic expressions, E gives E plus T or E minus T or T. T gives T star F or T divides F or F. F gives IE or ID. Okay, so here if you see it is having a form of something like this, isn't it? So you have here E gives E plus T. So if you consider plus T as alpha, and this as A, okay, and this as A, right? So it is similar to this particular production derivation, right? So it has a left recursion and this as well, okay? And this is A and minus D is alpha, right? This is also left recursive. Here, this is alpha and this is alpha, right? This is A, and this is A. This production also has this non-terminal. What are the productions from this non-terminal is also having a left recursion. But whereas in F, you see the leftmost symbol is not A. If you consider this as A, it is different. And this one is also different. So this is non-left recursive, right? These two are left recursive. So this kind of grammar cannot be used for top-down parsing. So we have to rearrange the non-terminals such that the grammar is equivalent to this grammar, but it doesn't have this form. Okay, A derives A alpha, this form. So after seeing these steps, we will rewrite this grammar according to the steps how to eliminate the left recursion. Any doubts on what is a left recursion? All of you understood what is a left recursion?
Yes, ma'am.
Okay, good. Now, for eliminating left recursion, we have two rules. Okay, so two rules for elimination of left recursion. Okay, so the first one is if you consider this grammar for writing the rules. Consider the grammar. Make a note of this, all of you, quickly. It should be there in your notebook because you can refer this. Okay. Because whenever the top-down parsing problems come, they will not specify whether the given grammar is left recursive or left factoring is there or not. It is your duty by checking the grammar, you have to identify the left recursions and left factoring and eliminate and then only take the grammar. Otherwise, what happens is your whole parsing problem will go for a toss. Then later don't come to me. Okay, because the grammar itself will be left recursive, you will never get the proper answer. Okay, so these two steps you have to perform before you take the grammar for left top-down passing problems, right? So consider the grammar. A produces A alpha 1, A alpha 2. It's a general grammar, okay? So A alpha 3. And there could also be some expressions which doesn't have A part in it. So I will call them as B1. Okay, B2, B3, Bn. All right. See, in this grammar itself, this is of the form A alpha 1. Okay, this is of the form A alpha 2. But what about this? T. T doesn't have E with this. So it's not left recursive production. So it is of the form B, which is not having A. Okay. So once you identify these forms, you have to rewrite this. Then rewrite it as first step is to identify alphas and betas. Okay, then once you identify alphas and betas, then rewrite this as A produces beta 1 A dash.
This was there in FF. This was there in FF.
It was there?
We did that for GNF.
That's
Yes.
good. Okay. But I don't know how many of you understood properly. So I'm explaining it again.
It was a 10-mark question, ma'am.
Okay. Then guide me through, no?
That most of us didn't.
Beta M,
Beta M.
then A dash derives alpha 1 A dash, alpha 2 A dash, so on, and epsilon at the end.
Correct. Good, then my task is simple. A dash. Then just independent of is independent of A term, right? Then alpha is having A term. So whenever a grammar is given, you have to identify A, alpha. A is evident, alpha and beta, and rewrite them to get the non-left recursive grammar. Then why you didn't understand when I was writing the non-ambiguous part of this in the beginning? Okay, beautiful. Now, rewrite this grammar, applying this rule. So how do you write?
Beta is still beta M, right? Not N.
M, yes.
Okay.
M. It can be different, right? It's not the same.
Yes, ma'am.
So here we have already identified this is beta, right? So E produces, you have to introduce a new non-terminal. Beta 1, so beta 1 is T here. So T, E dash, right? Only one beta 1 is there. Then E dash, I have to write the production. So alpha is plus T, E dash, or minus T, E dash, and an epsilon. Okay, so this is split into 2. Okay, E is split into 2. Likewise, for this particular production, so T produces F as beta here.
T.
Yeah. F T dash, T dash produces star F T dash, or divides F T dash, right? Or epsilon. And here we don't have a left recursion. So here what happens whenever you get a problem in top-down parsing, first you have to eliminate the left recursion if it is there. Sometimes what happens in a given grammar, you will have both left recursion and left factoring. Okay, so you have to remove both of them. Once you eliminate one, you have to check for the other. Okay, so the final thing is, before top-down parsing problem you start, the grammar shouldn't have left recursion or left factoring. You cannot say I have removed left factoring and it is free of left recursion. You may have to perform left recursion after doing left factoring, or you may have to do elimination of left recursion first and then left factoring. That is also possible. So you have to see both before you start a problem. Okay. So we'll couple of. And one more thing is, this method removes immediate left recursions. Okay, if you have a cycle or epsilon productions in the given grammar, here you don't have a cycle or epsilon productions, then this algorithm might work, might not work. Okay, so suppose you have a grammar in this way. So what did you do if the cycles were there in FAFL?
Initially itself will remove all the productions, epsilon productions.
So here epsilon is also there and the cycle is also there. How will you remove?
We will substitute for 1.
Then you can do it. So an algorithm is given. Usually the questions will be explain the algorithm of for eliminating left recursion, you can go with the formal notation of writing the algorithm like input output algorithm, which is there in the book. Otherwise, you take an example and you can explain with the help of this. If you feel that is difficult, the formal notation, then you should write this and state that it's for immediate left recursions only, and for cycles we have to substitute and do it. Okay, the algorithm is there in the book, and I will also give it in the notes, which is not required here. You should know how to do it. Okay, usually a problem they will ask because since this unit has lot of problems in it, top-down parsing, error handling in top-down parsing, bottom-up parsing, you have 3 types. So rarely this might come in what do you say, short like 2 marks or 1 mark in the quiz. Okay, this type of problems. In detail, write an algorithm, it might not come for your finals. Okay, usually they'll go with top-down or bottom-up parsing problems. You can guess the problems here, right?
Ma'am, how do we solve those cycle problems? Like cycle is found in the sense S is calling A and A is calling S.
So here you don't have a immediate left recursion, right? So you write this as it is. Here what you have to do is you have to substitute once. Instead of S, you have to substitute AAD, or one more is there, right? So BD or epsilon. Now you get S. So this is beta, and you have to take epsilon as beta 2 and apply this step. Okay.
Yes, ma'am.
Yeah. I'll give you some of examples. You try with this, all of you.
Also, like, what is left factoring?
I will
left
tell you.
recursion.
Yeah, I will tell you that. First, let us finish left recursion, and then we'll go to left factoring. Okay. So this was. So this is alpha 1, it's alpha 2, this is beta 1, this is beta 2. For people who forgot how to do it, I'm just doing it. So S gives A or B. So how do you write? A gives beta 1, A dash. So BD, A dash, then or A dash, because epsilon is beta 2. Epsilon A1 is, A dash is nothing but A dash. From A dash, it is alpha 1, T A dash, right? Then AD, A dash, or epsilon. Okay, this is the non-left recursive grammar. Okay, for this. Then take one more example. CD or E. B produces D or E. So you have a left recursion in this particular production, right? So split up and write the production. These are all for your reference. You have to practice problems. B or T or D. T derives, T produces D and F or A. F gives true, false, or now here or and true, false, all of them are what?
Terminals.
Yes, they are terminals. S produces A or L. L produces L, comma S or S. Then yeah. One more declaration statement I will give you. T produces TV. T produces int or float. V produces V or D. V and D and D or W. I hope you are doing it. First one is S produces SL or M or C, L star M, and M produces M plus W or LS or try solving or take down the questions and you can solve one or two, and if you have any doubts.
Ma'am, the fifth one, that M production, that LS, that S is a terminal, right?
S is
In the M production, ma'am.
no, it's not terminal. It's
Okay,
a
so
non-terminal.
S only. Okay, ma'am.
See, until you find out that in this case, what happened when you substituted, you got the left recursion. If you don't get a left recursion, don't substitute and make the life complicated. Don't substitute. It's not required. If at all, if you get a left recursion because of the substitution, then only you do it. Otherwise, substitution is not required because it is harmless. Others, any doubts? I see interaction from Dinesh, Furkan, Harish, Srishti, Kriti. Only few guys. Others are not at all talking. Why is that? You're understanding, you're not understanding, you have any doubts, you're not at all telling me. Giridhar, Gracious, Guransh, Girls, Rishika, Kirti, Ayush. Skanda is also talking to me. And I think even Sumit is talking. Sometimes Tejas and Sumit. Others are not at all talking. And the attendance is also very low. 62 on 80 is not a good number. Yes, Manjunath, Manoj. Understood?
Yes, ma'am.
Okay. If you have any doubts, you have to tell me. Solve this problem, no? I can just help you with alpha, beta, finding alpha and beta. You can rewrite. So here I'm not finding any alpha and beta because I don't have a recursion. So here I have, so this is alpha 1, this is alpha 2, and this is beta 1. You know how to rewrite this. And this production and this productions are kept as it is. Here, so remember, even if I have more number of terminals or non-terminals after this, all belongs to alpha 1 only. Okay, don't just take OR as alpha 1. So this is A and this is alpha 1 and this is beta 1. Here also, and F is alpha 1 and this is beta 1. Here we don't have a recursion, so you can rewrite that. Now here, you don't have a recursion. So here, what is comma?
Terminal.
Yes.
Terminal.
Yes, correct. So it is alpha 1. Even if you substitute for S, you have to substitute as A and this one, okay, brackets L. So it doesn't give you a recursion, so it is harmless. So you can take this as beta 1, okay? Then you can continue. So here you have a left recursion. So this one is alpha 1, this is beta 1, and this is beta 2. Here you have a recursion. So this is alpha 1, this is beta 1, and this is beta 2. Here also you have recursion. So alpha 1, this is beta 1, and this is beta 2. So if you substitute for L, you get L star M, W, and A. It doesn't start with M anywhere. So it is harmless. Okay, even here if you substitute for M, you get M plus W, LS, and B. So nowhere you get S at the left hand side. So it is also harmless. So you need not do it. Okay, so that is how we can do it. Now here there is no left recursion. Here also there is no left recursion. So left recursion is there only here. So this is alpha 1, this is alpha 2, and this is beta 1. Any doubts? Okay, so I just erased this part. If you haven't taken down the grammars at this site, you can take it.